Hello. Can you guys see the notes on there? Okay, good. All right. All right, 5.5 is about real numbers. Okay, so again, we've talked about some of these things before. Natural numbers, those are your counting numbers, 1, 2, 3, 4, 5, etc. Whole numbers is basically the same thing, except for it also includes 0. And then integers includes all of the whole numbers, plus it also includes all of the negative whole numbers. And then rational numbers, so that's any number that can be written as an integer over an integer. Okay, so we talked about this last time, basically fractions or decimals that can be written as a fraction. And then irrational numbers, so this would be anything where the decimal goes on forever with a random pattern. They're not a pattern, but just a random bunch of numbers. So for example, square root of 2 or pi. So the set of real numbers contains all of the rational and irrational numbers. Okay, so every real number is either rational or irrational. Okay, so the closure property of addition and multiplication means that the sum or product of any two real numbers is a real number. Okay, so no matter what two real numbers, if you add or multiply them together, your answer is always a real number, right? So, 2 times 3 is 6. That's a real number times a real number equals a real number, right? And then addition and multiplication are both commutative, which means changing the order does not change the answer, right? So 2 times 3 is 6, and 3 times 2 is also 6. Or 2 plus 3 is 5, and 3 plus 2 is also 5. That's commutative property. And then associative property just means, wherever you put the parentheses with your addition, that doesn't change the answer. Same thing with multiplication. So if you have, 1 plus 2 plus 3, it doesn't matter if you add these two first and then this one, it's still going to be 6. Or if you add 1 plus 2 plus 3 and you add the 2 plus 3 first and then add the 1, either way, it's still going to be 6. So that's the associative property. And then there is the distributive property of multiplication over addition. Okay, so for example, let's say you have 2 times 3 plus 4. So that is the same thing as 2 times 3 plus 2 times 4. So like if you did it this way and you added the 3 plus 4 is 7, and then that would be 2 times 7, which would be 14. Or you could do it this way and do 2 times 3 is 6, plus 2 times 4 is 8, and then 6 plus 8 is again 14. And then the identity property of addition means that 0 can be deleted from a sum. So a plus 0 is still equals to a. Okay, so it's pretty obvious. The identity property of multiplication means that 1 can be deleted from any product. So a times 1 is equal to a. Inverse property of addition. So the sum of a real number and its additive inverse gives 0. So that's the additive identity. Okay, so a plus negative a equals 0. Or in other words, 2 plus negative 2 equals 0. So negative 2 is known as the additive identity of positive 2. Or positive 2 is the additive identity of negative 2. I'm sorry, well, actually, I think I said that wrong. Negative 2 is the additive inverse. So negative 2 is the, sorry about that, is the additive inverse of positive 2. And you could say vice versa. Positive 2 is the additive inverse of negative 2. Okay, so the additive identity is 0. Because that means that's the number that you can add to anything and it doesn't change the number. Okay. Inverse property of multiplication. So the product of a non-zero real number and its multiplicative inverse gives 1. That's the multiplicative identity. Okay, so a times 1 over a equals 1 as long as a is not 0. So for example, 2 times 1/2 would equal 1. So we could say that 1/2 is the multiplicative inverse of 2. Multiplicative inverse of 2, or vice versa. And then 1 is the multiplicative identity. Okay. All right, so let's give some examples of an integer that is not a natural number. Good. Okay, so an integer that is not a natural number. So any negative integer would be an example of an integer that's not a natural number. So besides negative numbers, what's one other example you could give? 0. 0 is an integer, but it is not a natural number. All right, number 2, let's give an example of a rational number that is not a whole number. exactly. 1/2 would be an example. 0.6 would be another example. -3/4 would be an example. Okay. All right, number 3, choose a number that is an integer, a natural number, and a whole number. 2, 127. Any natural number is also a whole number, and it's also an integer. All right. Number 4, use 2 numbers to show that the set of natural numbers is not closed with respect to subtraction. So that means it is possible to take 2 natural numbers and subtract them, and your answer is not a natural number. So for example, 3 minus 7. Okay, 3 is a natural number and 7 is a natural number. But if I subtract them, my answer is -4, which is not a natural number. So that shows that the set of natural numbers is not closed with respect to subtraction. It's possible to subtract 2 natural numbers and then get an answer that's not a natural number. But it is closed with respect to addition. So if you take any natural numbers and you add them together, your answer will always be another natural number. All right. Any questions? Okay. Number 5, use 2 numbers to show that the set of irrational numbers is not closed with respect to multiplication. Okay, so that means I need to find 2 irrational numbers that I can multiply together, and my answer is not an irrational number. Well, irrational, remember, irrational, yeah. What kind of numbers are irrational? Right, like the square root of 3 would be an example. So the square root of 3 is an example of an irrational number. If you multiply that by the square root of 3, which is also an irrational number, of course, your answer is 3. And 3 is not an irrational number. So the set of irrational numbers is not closed with respect to multiplication, because there is a possibility you can multiply 2 irrational numbers and get an answer that is actually rational. All right. Okay, let's see. Number 6, the algebraic expressions d times a plus 1 all over 24 and dA plus d over 24 describe the drug dosage for children between the ages of 2 and 13. In each algebraic expression, D stands for the adult dose and A represents the child's age. Name the property that explains why these expressions are equal for all values of D and A. So what property makes those 2 expressions equivalent? The distributive property. Because if you just distribute the D there, it gives you that. Okay, so that is the distributed property. Okay. Okay, so part B, if an adult dose of a certain drug is 200 milligrams, what is the proper dose for an 8-year-old child? Use both forms of the algebraic expression to answer the question. Okay, so it says that, so adult dose, that's D, equals 200. And then A is the child's age, so A equals 8. Okay, so that would be, if we use the first form of the expression, that would be 200 times 8 plus 1 all over 24. So 8 plus 1 is 9. So 200 times 9 over 24. Okay, so 200 times 9 would be 1800 over 24. So that would be, let's see. Well, okay, let's just divide it, I guess. How many times did that go in there? Maybe 8. Oh, that's, oops. Okay, yeah, 8's too many, so maybe 7. Okay, 168, that would work. Okay. So then 180 minus 168, that would be 12. And then 24 would go into 120. How many times? Would that be 5? So 75. All right. So then what would it look like if we use the other form of the expression? So it would be 200 times 8 plus 200 all over 24. And so that would be 1600 plus 200 over 24. So it's basically the same. Neither one's any easier. All right. Let's look at evaluating expressions. All right, so a variable is a letter used to represent an unknown value that changes or varies. And technically, I guess it doesn't have to be a letter, but it pretty much always is, isn't it? You could use a heart or a smiley face or a tree or whatever. My dad always likes this example that he had a teacher like in school that told him, you know, you could have like 2 pink fish plus 3 pink fish. And you would draw pink fish on the board or whatever. I mean, for whatever reason, that just stuck with him. My dad always tells me about how the 2 pink fish. You know. So that could be your variable, could be pink fish. All right. So a constant is a real number that does not change. It's called a constant. An expression includes variables, coefficients, constants, and operations. It might not include all of those, but it can include any of those. To evaluate an expression means to replace any variables with numbers given to find the value. Okay, so number one, identify the parts of the expression as variable, constant, or coefficient. Okay, so 7 is the coefficient. Okay, and B is the variable. And 5 is the constant. All right. So 7b minus 5 is an example of an expression. 5 is the, or I guess I should say, I guess we could say negative 5 is the constant. Whatevs. Okay. So number 2, the expression for ordering brushes for an art class is 3c minus 5, where c is the class limit. Evaluate the expression when the class limit is 23. So that just means we're going to put 23 in place of c. So that would be 3. So 3c means 3 times c. So we're going to do 3 times 23 minus 5. So 3 times 23 would be 69. And then 69 minus 5 would equal 64. All right, so I guess that means they should order 64 brushes for that class. All right, number 3, evaluate the expression b squared when b is negative 1. Okay. So negative 1 squared. So negative 1 times negative 1 equals positive 1. Okay. Evaluate the expression when x is 5, y is negative 3, and z is negative 4. And the expression is the absolute value of xy, which means the absolute value of x times y, plus the absolute value of xyz. Okay. So that's going to be absolute value of 5 times negative 3 plus the absolute value of 5 times negative 3 times negative 4. Okay. All right, so I've got everything plugged in there. So now I need to basically use PEMDAS to solve this. So 5 times negative 3, so we do that first. So the absolute value bars in this case are kind of like parentheses. We want to do what's inside there first. So 5 times negative 3 is negative 15. And I'm going to bring down the absolute value plus, okay, and then I'm going to do this multiplication. So 5 times, so, you know, it's all multiplication, so I already know like those negatives are going to cancel each other out. And it's just going to end up being a positive. So I can even say, okay, I know 3 times 4 is 12, and then 12 times 5, that would be 60. That's 60. And again, I'm going to bring down the absolute value symbol. All right. So the next thing I need to do is actually evaluate the absolute values. So the absolute value of negative 15 is positive 15 plus the absolute value of 60 is 60. So it's 15 plus 60, which equals 75. And that's my final answer for that. Any questions? All right, number 5. All right, evaluate the expression when y is negative 4 and z is negative 12. And the expression is z squared over negative 3y plus z. Okay. So y is negative 4 and z is negative 12. So we're going to have negative 12 squared. All right, and we're putting parentheses around that because, you know, the whole nut thing is squared, the negative included there. Over negative 3 times negative 4 plus negative 12. All right, so the fraction bar is like a grouping symbol. So we're going to do the numerator as one group and the denominator is another group. So negative 12 squared. So that's negative 12 times negative 12. So that's going to equal positive 144. All right, and then we can work on the denominator. So within the denominator, the first thing we would need to do is multiply negative 3 times negative 4, which would equal positive 12. So I've got positive 12 plus negative 12. So 12 plus negative 12 equals what? 0. So I'm looking at 144 over 0, which is undefined. 0 under undefined. All right, number 6, evaluate 13 minus z for z equal to 4. So that would just be 13 minus 4 equals 9. Number 7, evaluate 5x plus 4 for x equal to 9. So that would be 5 times 9 plus 4. So we're going to multiply 5 times 9 equals 45. And 45 plus 4 equals 49. Number 8, evaluate 2 times L plus W for L equals 9 and W equals 1. Okay. So 2 times 9 plus 1. So I'll just go ahead and do what's in the parentheses first. So 9 plus 1 is 10. So it's 2 times 10 equals 20. Number 9, evaluate the given expression for x equals 5 and x equals 7 and y equals 5. Okay. All right. X equals 7. That's 2 times 7. Minus 5 plus 15 over 2 times 5 minus 7. All right. So let's work on the numerator. So 2 times 7 is 14. So I have 14 minus 5 plus 15. And on the denominator, I could go ahead and do 2 times 5 on there. So 2 times 5 is 10. And so I have 10 minus 7 on the denominator. Okay, and then on the numerator, so 14 minus 5 would be 9, plus 15 would be 24, and then 10 minus 7 equals 3, and then 24 over 3, so 24 divided by 3 equals 8. All right, and then number 10, evaluate 5 times x plus 7 for x equals to 3. Okay, so that would be 5 parentheses 3 plus 7, and then do what's in the parentheses first. So 3 plus 7 is 10, and then it's 5 times 10, so that equals 50. All right, anybody have any questions about that?